Textile and clothing companies need to release new fashion collections in less time to stay successful. But today the development process for new collections is a bottleneck, since several physical prototypes need to be created before the final design is found. The European project Future Fashion Design, FFD, has developed an integrated approach to support product development by virtual prototyping at a new simulation quality and process integration level. Jörn Kohlhammer, head of the Information Visualization and Visual Analytics Department at Fraunhofer IGD, explains the motivation of the project.
Future Fashion Design is a project that comes from a business idea. We wanted to support the customers of the computer-aided design software in a more proficient way.
The product development process in the garment industry is highly iterative, based on physical mock-ups. This means a high restriction on the speed of the product development, which would be dramatically increased by applying virtual product development technologies.
Alessandro Canepa of Piacenza, a high-quality fabric producer from Italy, explains the challenges and efforts of the traditional product development process.
The first step of the traditional process is the selection of the raw materials. After this step, there is the production of the yarn. When we receive the yarn from our sub-suppliers, we create the warp, and then we start the weaving process. When we realize the samples, we have to create per each piece different colors, so the warp is divided into different pieces, into different colors, in order to create all the combinations which are expected from each fabric. The fulling is the process when the fabric is shrinked and it loses about 20% of its length and width, and it becomes thick. This part of the process prepares the raising. It is the process part where the fibers are taken out from the surface of the fabric. The raising gives the characteristics finishing have, the surface characteristics and the touch. After the raising, there is the final part of the dry finishing and the quality control. To give an idea, we have per each collection about 200 or more fabrics, each one with all its color proposal, which can reach about 40 colors for some fabrics. The objective from a FFD project is to pass to this traditional kind of proposal to a new one, where we realize only one sample of fabrics and all the different colors are realized only virtually.
But not only the fabric industry can benefit from virtual prototyping. Also, the garment industry has a need for the FFD approach, as the traditional development process at Consitex, a clothing manufacturer from Switzerland, shows. The traditional process starts with a meeting between the creative team and the pattern maker to discuss the new collection. The creative team develops a first sample based on sketches, pictures, and vintage garments. Based on this information, the pattern maker starts his work on the first prototype. In a preliminary check, features like pocket size or collar fit are modified and optimized. At the end, a final CAD template is given to the production unit and the manufacturing process begins. Fabrics or linings are being cut and delivered to the sewing factory. Here, the prototype receives its final shape up to the final assembly of all garment parts. Once the prototype is ready, the pattern maker checks the final result before sending it to the creative director. If the pattern does not match the expectations, a new redesigned prototype will be carried out. But although virtual prototyping can facilitate this process, its dissemination in the garment industry has not been very successful so far. Jörn Kohlhammer knows why.
So currently we have the problem that garments are simulated on a very broad level, which means that you have textiles and you try to acquire from real textiles how these garments should look like. and then you try to come as close as possible to the simulation process. The next step that we really wanted to acquire with future fashion design was that we go to the yarn level to really know how is a garment structured and then simulate with this knowledge.
Our prime role is to get the visualizations to such a degree that they can send a digital version of those fabrics to the customer, perhaps as a flat visualization or even better as a three-dimensional garment visualization. The 3D models have been provided and modelling software is provided by IGD. We generate ultra-high resolution textures for this specific purpose, so that for 3D models of garments, whatever the shape may be, we can actually zoom in virtually to fibre size itself, so we can get incredible realistic visualizations.
The biggest step that we take in future fashion design is that we enhance the rendering algorithms, so to the look of textiles, the look of the garment, and take this and enhance this even further than before. So what you can do now is on the yarn level you can really see different yarns in the textiles that are used for the virtual garment. You can change colors in real time, and you have additional lighting options for the rendering in the garment simulation.
So the part of Assist in this project is to extend the existing 3D simulation engine by a new adaptive meshing technology, which provides the possibility to simulate even highly complex products such as main suites with a sufficient quality and accuracy and speed.
Video is a tool to display exactly the 2D pattern in a 3D environment, where you see the material characteristics, you see the shape of the pattern pieces and the relation of the pattern pieces to the body. The aim of the tool is to give you an immediately feedback to the quality of your pattern making and fit, with only doing a real prototype in the end of your process. So whenever you're decided that now you have the right fit, you have the right materials chosen, then you would go into the physical sampling process, just to reduce the number of iterations from usually 3 to 4 iterations to basically 1 or 2 iterations on a model.
Another result of the FFD project is the Collaborative Design and Prototyping Platform, CDP, provided by ATC, a web application provider from Greece. Jon Kohlhammer explains its benefits.
So, a really important aspect of future fashion design is the new business process that is completely on the virtual side. So we start with a virtual fabric and then go towards the virtual garment without going back and forth between the real world. And the CDP is a platform to support exactly this new virtual business process.
Introducing the virtual product development in the garment industry means that the processes are dramatically changed, and as this technology is not really in use currently in the garment industry, this means a dramatically increase of potential market value of our products.
What happens is that they create one physical sample. This is the future. They create one physical sample and 50 digital samples. So the savings are, you cannot overemphasize the savings.
We have to find a good balance, because textile is really an artistic sector, but we have to consider that, like in other sectors, the IT tools did not limit the creativity, but also gave a support to widen the possibilities of new proposals, free from the constraints of the physical production, of the costs and of its timing.